Hello my dear students, today I am going to show you an awesome solution to the toughest question of JEE Mains 2025 Physics. Okay, so this solution is going to be a single step solution, mind-blowing solution, amazing solution. Okay, and you are going to love this solution which I am going to tell you. So I'll be discussing two things. The first is a standard solution which is there, and the second is the awesome one step mind-blowing amazing solution. Okay, so listen to the two and let us go ahead to the question. So let us see this question. Consider a long thin conducting wire carrying a uniform current I. Okay, so we have this conducting wire carrying a uniform current I. A particle having mass m and charge q is released at a distance a from the wire. So a charge is released at a distance a from the wire with speed v naught along the direction of the current in the wire. So let us have a look. Okay, so this charge is released in this direction. The particle gets attracted to the wire due to the magnetic force. So we can see that this particle is getting attracted to the wire due to magnetic force. The particle turns round when it is a distance x from the wire. So when it is at a distance x from the wire, the particle is coming back and turning around. That means its velocity is becoming opposite to that of the initial velocity. The value of x is, so what is this distance at which the particle turns around? Okay, so this is what we need to find. Let us first go to the standard method. So this is the standard method, and here what he has done is he has taken 3 points a, b and c, and velocity at some random location he has taken velocity as vxi cap plus vy j cap. He has written the magnetic field. Also he has written the magnetic force in vector form. Then he has found the acceleration of the particle. Okay, and integrated that acceleration from a to b and found the coordinate of b. After finding the coordinate of b, again he has done the integration, and from b to c again the integration has been done, and finally he has got what is the value of x. You can see that this is a lengthy process, requires long integration, lots of steps. There is large probability of making silly mistakes. Okay. So now I'm going to show you awesome solution wherein we can complete our question in just a single step. Okay, so let us see this. So this is the charge. Initially it is a resistance A from the wire. Okay, and let us see what happens next. Okay, so the charge starts from here. So first point is, as there is only magnetic force acting on the wire, magnetic force does not do work on this charge. Magnetic force is acting on the charge. Magnetic force does not do any work on the charge. So which means the speed of the charge will remain constant. So you can see that this blue vector here is the speed of the charge. The length of this vector is always constant and it is not changing. Next, this is the magnetic force. Okay, when the charge is nearby, the magnetic field is higher and the magnetic force is higher here. Here, magnetic field is less, force is also less. You can see as it is coming here, the force is increasing in magnitude. The length of this arrow is increasing. Okay. Okay. Now let us come to the awesome solution. Okay. So let us say the particle is here. Let us say the particle was here. Okay, it has gone here like this, and let us just divide this. At this instant, it is a resistance x from the wire. Just writing this as x. Okay, and this is dx. This is r d theta, I'll tell you what is the method that we are using here. Okay, the logic behind this method is that as this radius is there, right? It is not constant. It is going on changing. As this is rotating, what happens is this subtends an angle theta with the horizontal, right? So when this theta was 0, the distance, the x was a. When this theta becomes 180, he's asking us what is the distance from the y. So we need to bring a relation between theta and x. Okay. If we can bring a relation between theta and x in one step, our problem will be over. We can just use the limits and we can complete it in one step. So let us see what to do. Now, if this is dx and if this is theta, with the vertical, this makes an angle theta. I can write dx. So this is rd theta. I can write dx as r d theta sine theta. Okay, r d theta sine theta. As theta is increasing, the value of x is decreasing. So dx is a negative quantity. X final minus x initial is a negative quantity. Our LHS is negative and RHS is positive. To make this equation consistent, I have to put a negative sign here. Okay. Now the next step. So dx equal to, see what is the radius of curvature of this path here? I can write this as AC equal to V square by R. Okay. Or R is AC, V square by AC. V square is it changing? The velocity is not changing. Acceleration is always perpendicular to the velocity because it is a magnetic force, right? So I can directly write this R as minus V naught square divided by, what is AC, tell me? Magnetic force by mass is acceleration. What is the magnetic force? Q V naught. QVB is a magnetic force. So Q V naught, what is the magnetic field when it is here? It is mu naught I by 2 pi x. That is a magnetic field. Divided magnetic force divided by mass is the. So we have written what is R, okay, into sine theta d theta. That's it. That's it. We have got a relation between x and theta. Now if you just put the limits, the question is completed. Okay. So let us put the limits here. See, we can now cancel out v naught here, and dx by x equal to negative 2 pi m v naught by q mu naught I sine theta d theta. Okay. And limits. Let us put the limits now. See, when theta was 0, what was x? It was a, right? When theta was 0, x was a. When theta is pi, okay, when theta is pi, what is the x distance from the pi? Anyways, this is a constant. What is integral sine theta d theta from 0 to pi is 2. So directly, now I can write this as, I'll just write this here. This is nothing but, ln x by a, okay, ln x by a equal to negative sine theta d theta 2. I'm just keeping it here. It becomes 4 pi m v naught divided by q mu naught I. Okay, and that's it. Now just take e power directly from this. We get this one, a e power minus 4 pi m v naught by q naught I. So you can see that in our solution, this was the main step. After this, it is nothing. Okay, and when you compare it with this solution, the other solution, you see the solution, long solution, lengthy solution, high chance of making this silly mistakes here, right? Okay, so yes, students, this is the awesome solution which I have showed you today, and see you all for the day. Bye bye. See you.